Hello everyone, welcome to my YouTube channel Chemistry Quest. This is the fifth lecture on polymers chapter. This is useful for class 12 board exams as well as CUET exam. So in this video we will be discussing two topics, molecular mass of polymers, and we will discuss some important polymers of this chapter given in NCERT book. So let's get started. Now first let's see some basics related to molecular mass of polymers. We know that polymer properties are closely related to their molecular mass, size, and structure. The growth of the polymer chain during their synthesis is dependent upon the availability of the monomers in the reaction mixture. Thus, the polymer sample contains chains of varying lengths and hence its molecular mass is always expressed as an average. Therefore, the molecular mass of polymers can be determined by chemical and physical methods. Let's see some more details about this topic. Now, for a given protein, all its macromolecules have identical constitution and molecular mass. However, most synthetic polymers contain a mixture of macromolecules of different molecular masses in a certain range. For this reason, their molecular masses are expressed as an average of the molecular masses of the individual molecules. It is expressed in two ways. First is the number average molecular mass, and second is the weight average molecular mass. These are the two methods by which molecular weight of polymers is calculated. Let's see the first method, number average molecular mass. How it is denoted? It is written as M, molecular mass, number, and this bar signifies the word average. So the formula of this calculation is Mn bar is equal to N1 M1 plus N2 M2 plus N3 M3 and so on divided by N1 plus N2 plus N3. It can also be written as in simplified form as summation Ni Mi divided by summation I Ni. This is the formula of the calculation of molecular mass average. Now, here we have to remember some important points is that Ni is the number of molecules of molecular mass Mi, as we have seen in the slide, and Mn is determined by employing methods based on colligative properties such as osmotic pressure, which is related to number of molecules. This is a property of colligative properties that it is dependent on the number of molecules present in the reaction mixture. Now, the second way of calculating the molecular mass of polymer is that weight average molecular mass. It is denoted by symbol M, W here in the subscript, and average like this. It is defined by the expression weight average molecular mass is equal to summation Ni Mi square divided by summation Ni Mi, where Ni is the number of molecules of molecular mass Mi. This is about the second method. And we have to remember some more important thing is that Mn and MW average, they are the two different methods. So second method is determined by employing methods based on such properties which are dependent on mass of individual molecules. They are not dependent on its number. So the MW, that is average weight, is not dependent on colligative property, dependent on colligative property property. Hence, light scattering and ultracentrifuge methods are useful in this respect. This is about the molecular mass of polymers. Now we have to discuss some polymers which were left. So first is the propene. So propene is the monomer. This is the polymer. This is the polymer, and this is the uses, and this is the name of polymer. So first is polypropene. So monomer is propene, and the what happens actually during polymerization is that suppose we want to make the propane. So CH2, so CH, so CH3. So the double bond will convert into single bond, and single bond will convert to double bond if needed. Otherwise, the double bond will free its valency. So polypropene is the name of the polymer, and its uses is making of pipes, toys, and fibers and ropes. Second is the polystyrene. Polystyrene, the monomer is styrene. So this is the polymer of polystyrene. It is used as an insulator, wrapping material, manufacture of toys, radio, and television cables. This is about the polystyrene. Next is vinyl chloride. So this is CH2 double bond CHCl. This is vinyl chloride. When this vinyl chloride monomer undergoes polymerization, it forms polyvinyl chlorides. That is double bond and gets free. It becomes a single valency. So it is used in the manufacture of raincoats, handbags, vinyl flooring, and water pipes. Next, we have to study two important polymers. First is urea formaldehyde resin, and second is glyptyl. So first is urea formaldehyde resin. In urea formaldehyde resin, the name suggests that the monomer is urea and formaldehyde. Urea structure is NH2C double bond O NH2. This is urea. And formaldehyde is HC double bond O H. This is formaldehyde. When these two combine, it forms urea formaldehyde resin, and it is used for making unbreakable cups and laminated sheets. Right? Now next is glyptyl. Glyptyl has two monomers, ethylene glycol and phthalic acid. So ethylene glycol, we all know that it is CH2OH. CH2OH. This is ethylene glycol. And phthalic acid is this benzene, benzene with having the COOH adjacent group. COH at the adjacent position. This is the phthalic acid. As we can see in these polymers, these three are homopolymers. Homopolymers. Why? Because they have the single monomeric unit. There is no involvement of two monomers. Whereas the last two, urea formaldehyde resin and glyptyl, they are copolymers. Copolymers. They have two monomers in their polymerization reaction. So this is all about this video. If you like this video, please hit the like button, share with your friends, subscribe my channel and hit the notification bell for upcoming videos. Thank you and have a nice day.